Okay, so let's solve another absolute value equation here. So for this particular example that we have an absolute value equation that is less than or equal to this -1 over here. When it comes to absolute value equations, remember it is important to see what kind of symbol you have going on over here because it's going to tell you how to work this example. So again, just backtracking a little bit here, absolute value equations, right? So absolute value means the distance a number is away from 0 on the number line, and distance is always positive. So absolute value bars always make everything positive, right? So considering that it makes everything positive, right, we need to figure out when it comes to solving here, we truly don't know if this x was the positive value or the negative value here. Like, so for example, how do we know that it was a 2 or a -2 in there? Because in the end here, these bars are going to end up making it positive regardless. Right? So when it comes to absolute value equations, we always need to take our given example and split it into two different problems here. And that always depends on the kind of equation or inequality you're given. So for this particular one here, we were given a less than or equal to. So to solve an absolute value equation where you have a less than or equal to, this is what you do. Your first equation is going to stay the same. Notice this is the exact same thing as here, this one here. That's going to stay the same. But your second equation, that's the one that's always going to change. Your second equation on the left side over here, the absolute value part, that still stays the same. Okay, this part over here will always be the same. The only thing that changes is that you need to flip the symbol, whatever it was. If it was less than, flip it a greater than. If it was greater than, flip it a less than. And then always take the opposite of that value. So if it was a positive number, change it to negative. If it was negative, change it to positive. So flip the symbol, change the sign, and that's your second equation. So looking at the given equation that I have here, so first thing that we need to do before we go and creating our two equations here is the one thing you need to keep in mind is that the absolute value bars have to be isolated on one side of the equation, which means these absolute value bars need to be by themselves. So if you have something hanging out over here, some number, minus a number, plus a number, you need to get rid of it. So we need to move that over to the other side. So since we have a -6 hanging out over here, I'm going to add 6 to both sides before we do anything. -6 plus 6 cancels, and let's drop down the absolute value of x plus 5, and then this is going to give me, well, -1 plus 6, that's 5. So this is the equation I want to work with. So we need to split it up into two equations. The first one is going to be our normal equation, just get rid of those bars. And then the second one is going to look almost the same, but we need to flip the inequality and we need to make our sign negative over there. These are the two equations that we need to solve. And honestly, for the most part, absolute value equations aren't that bad to actually solve. So hopefully at this point when you get into solving these, you are okay with solving equations, solving inequalities. If not, maybe backtrack and watch some of the videos based off of that. But otherwise, if we're solving for x, I have this plus 5, so we do the opposite and subtract 5 on both sides. 5 minus 5 cancels, and x is less than or equal to a 0. Right? 5 minus 5 is 0. I'm going to pause there and let's solve this one. So here we also need to subtract 5 on both sides. 5 minus 5 cancels, and x is greater than or equal to a -10. -5 minus another 5 is a -10. Now, one important thing about absolute value equations is that you need to get in the habit of always checking your answers in the end. Every once in a while, you are left with an answer that does not make sense. So you need to get in the habit of checking it. So when it comes to checking it, I'm just going to pull our original example right over here. Right? And what we're going to do is we're going to put in our proposed solutions for it. So our proposed solution over here was x is less than or equal to 0. So I can pick 0 or anything less than 0 and plug it in for x and simplify this. So you can pick 0, -1, -2, and so on. Pick any number that you want. I'm going to pick 0, and I'm going to plug 0 in over here, and I'm going to simplify this. Well, 0 plus 5 is a 5, and 5 minus 6 is a negative 1. Negative 1 is less than or equal to negative 1. It makes sense. So that means this solution is good. Doing the same exact thing, but let's take a look at our other solution over here. We got that x is greater than or equal to negative 10. So greater than or equal to negative 10, that means we can pick negative 10, negative 9, negative 8, so on, as long as it's greater than or equal to negative 10. I'm going to pick negative 10. Negative 10 plus 5 is a negative 5. But if we do absolute value of negative 5, that gives us a positive 5, and 5 minus 6 is a negative 1. And again, negative 1 is less than or equal to negative 1. So this one also works. When you're done checking your solutions here, you have one final step that you need to do. Almost always when doing or when solving absolute value equations, inequalities, a lot of times you do need to graph your answers on a number line. So if we do that, let's see, we're looking at the values negative 10, we're looking at the values 0, so I'm going to put those on here. Because we have the greater than or equal to, less than or equal to symbols, that does mean brackets on our numbers here. And we want everything greater than negative 10, so everything to the right of negative 10, and everything less than or equal to 0, so everything to the left of that 0. So we're talking about this space in between here. So greater than or equal to negative 10, less than the 0. This is what your solution graph should look like.